Let's talk about functions in C. So in this notion of top-down designs, right? If we look at a C program, it is really nothing but a whole bunch of functions. Typically, these large C programs has what's called main, right? This console point of entry coupled with a whole bunch of functions here. So the purpose of a function is to receive, right, zero or more pieces of data. So you can look at this function as this function receive a set of input, right? And does something, there's some business logic in it that, and it gives output. Sometimes the function doesn't return anything. That would be a void function, but generally there's an output that comes out, right? So this is function number one. And of course you can chain this, right, into, and this becomes the output of your function one, right? Becomes the input to function two. So you have function two right here, which gives rise, right, to output, right, another output. And this output could be the input of another function, right? So on and so forth, right? So this is, so let's say examine some of the functions that we typically see in C and then kind of go through this top-down designs more in detail. In a typical C program, right, everything starts with main, right? So this main is a function, right? And main, does not return, actually returns an integer here. So your console application starts with the main, right? And this main, as we saw from the previous learning, that there could be a whole bunch of function calls, function two, so on and so forth, right? And each function can also call, right, other functions as well, right? In this case, we'll call two, and right, so on and so forth. And these are kind of changed. So C in and of itself is a procedural, meaning there is no notion of object-oriented programming in C. What you end up with is a whole bunch of functions that calls, either each other or one after the other, to perform, some or all of the parts of the job to complete, right, your business logic. This is a better representation of what I was talking about, where in a console application, right, in C, you have a main, right, function. Now this main function calls function one, two, and three, and each of the functions that is called by main can also have other function calls, like function A, B, C, right, called by function one, D, right, called by function two, or E and F, right, called by function three. And sometimes you may have recursions, meaning a function could be calling itself, with the base condition to exit, or this function could also be calling this function, right? So it depends on what your business logic is like, but this is kind of a structural, representation of a typical C program. You can look at a typical function, right, which is this three-dimensional boxes here, right, that has some sort of, what I call business logic. Now, this business logic could be a whole bunch of statement, could be a control structure, could be a conditional expression, right, whatever this is. And there's going to be some stuff, right, what we call side effects. These are, effects or state informations about your program. Let's say, the color of this box or the movement, right? Or the velocity of the car, right? Depends on whatever it is you're trying to emulate using your program. These side effects could change, right? These states, right? The colors, the speeds and whatnot. That's important, part of your business logic. And these side effects could leave some, state changes, what we call state changes that impacts, right, the outcome of your program. And whatever this is, just remember that a function, can take 0 to more data, right? Sometimes a function does not have any parameters associated with it. So let's say a function f, right, with no parameters, that's fine too. And, in that case, there's 0. But sometimes a function could have, multiple parameters associated with it. So you can pass arguments, right, A, B, and C into it. So you can have more data passing it. So think of it as, right, this is being the top portion being the input. And then whatever happens, right, in the middle, the business logic, a function always outputs something. but it could also be void. So in this case, it would just be simply a void return, at the end of the function, nothing else. But if not, right, the function typically returns something. So this piece of data that gets returned, or what we call output, could be a collection of data, could be an array, right, with some elements inside, or it could be an integer, could be a flow, right? It doesn't matter. So whatever that is. So when a function is called, right, it receives some sort of input and it comes out with an output. Now, sometimes, and what this is saying, right, is that sometimes the sole purpose, let's say this function is f, the sole purpose of calling it a function is to introduce this side effect. Let's say the side effect means you're changing, let's say, the color of this object in programming, right? And that's it. There's simply no output. It simply just effects some changes, right, on the object. By the way, everything inside a computer at runtime, right, inside a program at runtime is called object. So that's what we call side effect, or maybe plural effects, right? Sometimes you will call a function simply just for this output. Maybe there's no side effect, right? We just want the output. So this output could be integer, let's say 1, right? Integer, string, double, right? Or simply just another object you're trying to, create or generate. So this is the reason why sometimes we see, let's say this integer function, this function returns an integer. You can say the a, right, equals f, something like that, right? So this is what is being used, right? You're calling a function for this value. Function's value is the value of the expression of the return statement. So return statement is an expression that evaluates with a value, and this value gets assigned, okay, assigned into this variable. So sometimes the function is used for that matter. Hopefully this clarifies, the usefulness of a function in C. And this also obviously applies to C++. We have a program here that takes two integer, right? This two integer input by the user, and multiply them to get your multiplication, the product. So this multiply is a function, and here we have just beneath the include, right, the pound include, we have what's called function declaration. So this function declaration is also what we call function signature, right? It's simply just a signature, and a lot of times you don't even need to mention this. The function signature basically just has the bare backbone, right? So at line 9, okay, line 9 right here, you can replace line 9 with this, multiply. All you need to do is to specify that there are two integer parameters in there, right, and a semicolon, right? The reason why we don't do that, but instead we add num1 and num2 is to help the user, especially beginners, to understand that a function declaration could also have a variable associated with this. But ultimately, whether you name this num1 x or y, or z or w, right, it does not matter. You can simply just write out the bare bone. This simply tells the compiler that, hey, in this memory space, there is a function, and this function takes two integer parameters. And then as compiler moves on to the main, it knows that this multiply function has been declared. So let's look at the next page that illustrates a little more about this. User enters two integer, and they become this and this two variables. So what we're doing here is at line 22, we invoke, right? This is a function invocation. We invoke this multiply function by passing in these two integer variables, and these two integer variables contains the two integers that the user just entered. And so let's look at what this is. So this is really an illustration of a function. We're calling a function's value for its value, right? Because this multiply returns the product of these two integers. And so immediately, as soon as we call this, and by the way, this portion is evaluated first, okay? And an assignment actually has a lower precedence, which means multiply, right? This entire function is evaluated first, which gives you an integer. And this integer is then assigned, right, into the product, which is another integer. and then you print this product out at the very end. So let's look at this multiply function and how it works. Line 34 through 38 shows how this product function is written. So the logic says that first of all, you have num1 and 2 formal parameters, right? This parameters list introduces num1 and num2, which you multiply together, right, in the return. So you can simply do that, or you can say, integer p, right, equals num1 times, right, num2, and then semicolon, and then you can simply just return p at the end, right? P stands for product. So this introduces what's called a local variable. But why do that when you can just return them, right? And in this case, make sure you put a parentheses next to the num1 and num2 for readability purposes. And this return statement simply produces a product of your two numbers as the input, num1 times num2.